So this is a video about applying the product rule for derivatives. So if the function you want the derivative of is in fact the product of two other functions, then we apply the product rule. So the product rule here says if I want the derivative of a function that is a product of two functions, the rule is take the derivative of the leading function, the first function, but leave the second function alone, just rewrite it. And then we add the first function is left alone now times the derivative of the second function. So if we want the derivative of x squared minus 2x plus 1 times 3x plus 7, we can do the following. So the derivative of y with respect to x is going to equal the derivative of x squared minus 2x plus 1 times 3x minus 7 plus x squared minus 2x plus 1 times the derivative of 3x minus 7. So again, we notice in each case we have our first function x squared minus 2x plus 1. We take the derivative of that function and we leave the second function alone. Plus, now the first function is left alone and we take the derivative of the second function. So if I take the derivative of the parts that I need to, that's indicated by this d sub x, so it indicates the derivative with respect to x. So the derivative with respect to x of x squared is 2x minus the derivative of 2x plus 1 is just 2, and times 3x minus 7 plus, now there's no dx in front of the x squared minus 2x plus 1, so it gets rewritten, and then times the derivative of 3x minus 7, which is just 3. And then via a little algebra here, so I'm going to distribute the 2x to the 3x minus 7, that's 6x squared, and then 2x times negative 7 is negative 14x. Then distribute the negative 2, so I get minus 6x plus 14. And then I'm going to distribute the 3 to the x squared minus 2x plus 1. So distribute the 3, I get 3x squared. Distribute to negative 2x, negative 6x, and then plus 3. And last but not least, I'm going to get together my like terms. So I have a 6x squared here and a 3x squared there. That makes for a total of 9x squareds. I have a negative 14x, a negative 6x, and another negative 6x for a total of, let's see, negative 14, negative 6 is negative 20, plus negative 6 is negative 26x's. And then finally, I have my constant terms, 14 and 3, which makes that plus 17. So this is our derivative, dy dx is equal to that function. Okay, we're going to try another one. Okay, so again, I have two functions being multiplied, and I want the derivative. Again, the derivative with respect to x. Make that one pink, and that one blue. It's going to be the derivative of the first times the second plus, and the first one is left alone, and we take the derivative of the second function. So let's go ahead and get to work here. So the derivative of x to the fourth plus 2 is 4x cubed times x cubed minus x squared plus 2x plus 9. Right? I don't take the derivative of that, I only take the derivative of one of the factors at a time, plus, now they switch, x to the fourth plus 2 times the derivative of the second function. So that's 3x squared minus 2x plus 2. Okay, and again, a little bit of algebra. 4x cubed times x cubed. I'm going to distribute that through all of the terms, actually. 4x cubed times x cubed is 4x. Oops. Make that actually look like a 4. 4x to the 6th. 4x cubed times negative x squared is negative 4x to the 5th. 4x cubed times 2x squared is plus 8x to the 4th. And 9 times 4, negative 36x cubed. Okay, now I'm going to distribute the x to the 4th, so that'll be plus 3x to the 6th minus 2x to the 5th plus 2x to the 4th, and then I'll distribute the 2 plus 6x squared minus 4x plus 4. Let me make that look like an actual plus sign there. Okay. And again, I want to collect my like terms. So I have an x to the 6th here and another x to the 6th there, so that makes 7x to the 6th. X to the 5th here and another x to the 5th there. So negative 4 minus 2 is negative 6x to the 5th. I have an x to the 4th there and an x to the 4th there. That makes 10x to the 4th. And then I have an x cubed here. And 6x squared there. And a negative 4x. And finally, plus 4. So that is our final answer of the derivative. I'm going to do a slightly different strategy for this. For some of you, this may work a little bit better in order to help you keep track of what needs to go where. And so what I'm going to do is I'm going to write down each of the factors that are involved. So I'm going to write down 5 minus x squared plus 4x cubed. And then below it, I'm going to write x plus 11. Now next to each of them, I'm going to write down the derivative of each. So the derivative of 5 is 0, so 0 minus the derivative of x squared, so that's negative 2x. Derivative of 4x cubed is 12x squared. And then the derivative of x plus 11 is just 1. Now what I'm going to do is make a ribbon here, and starting down in the lower left corner, I'm going to multiply that by the term that's on the top right, add to that the factor on the top left times the factor in the bottom right. So you can see I've kind of made a ribbon here. Okay. So what does that look like? So dy dx is equal to, so we said we start in the bottom left, right? Start in the bottom left times the top right. So x plus 11 times negative 2x plus 12x squared. And then plus top left times bottom right. And then I still have to do my algebra here, so I'm going to distribute the x. Negative 2x squared, distribute the x to the 12x, so that'll be 12x cubed. Distribute the 11, minus 22x, and then 11 times 12 is 132 x squared. And then the other one times 1, well, 1 is the identity, so I multiply anything by 1. It doesn't change that quantity, so 5 minus x squared plus 4x cubed stays 5 minus x squared plus 4x cubed. And of course, last but not least, I want to put together my like terms. So let's see, cubed is the largest term, so there's 12x cubed and a 4x cubed. That's a 16x cubed. And then squares, I have 132 minus 1 minus 2. So 132 minus 2 is 130. 130 minus 1 is 129 plus 129x squared, 129x squared. And then I have an x term here, linear term, minus 22x, and then my constant term, plus 5, dy dx. Okay? Alright, so let's try another one like that. Okay, this one's it's got a square root in it, so first off I want to note that that can be written as x to the 1/2 power, right? So again, what do? I write down the two functions, so I've got x to the 1/2 plus 3, and I have the function x squared minus 5x plus 6, and then right next to each of those I write their derivative. So the derivative of x to the 1/2, bring down the power, subtract 1, and then the derivative of 3 is 0, so I won't write that down. Then I go down to x squared minus 5x minus 6. That derivative is 2x minus 5. Okay, and remember we make the ribbon. Okay, starting down in the lower left, I multiply across. Okay, from lower left to upper right. So the derivative is x squared minus 5x plus 6 times 1/2 x to the negative 1/2 plus. Right, so I come over now to this side, that's where I add. Plus x to the 1/2 plus 3 times 2x minus 5. Okay. Again, algebra, distribute the 1/2 x to the negative 1/2. So that's 1/2 x to the 2 minus a half is 1/2, or 3 halves. 2 is 4 halves. So 4 halves minus 1/2 leaves us 3 halves. Minus 5 times a half is 5 halves. X to the first minus a half is x to the 1/2. Plus 6 times 1/2 is 3, or 1/2 of 6 is 3. X to the negative 1/2. Plus, I'm going to distribute the 2x. So 2x times x to the 1/2 is 2x to the x to the first times x to the 1/2 is x to the 3 halves. I add the exponents. And then the 2x times 3 is 6x. And then distribute the negative 5. Minus 5x to the 1/2 plus 15. Okay, gather together my like terms. I have an x to the 3 halves and another x to the 3 halves. So 1/2 plus 2 is 2.5. X to the 3 halves. And then any terms that have x to the 1/2, positive 1/2, I have 2 of those. Okay, so I have minus 5 halves minus 5. So let's see, minus 5 is the same as 10 halves. So minus 5 minus 10 is minus 15 halves, x to the 1/2. Let's see, any other terms that have a positive exponent on the x? That would be 6x, and there's only one term, plus 6x. And then I have x to the negative 1/2, so that's plus 3x to the negative 1/2, and then finally my constant term, plus 15. And if you want all of your coefficients to be the same, not mixed numbers, but improper fractions, 2.5 is the same as 5 halves, so I can change that to 5 halves, x to the 3 halves. Oops. X to the 3 halves minus 15 halves, x to the 1/2 plus 6x plus 3x to the negative 1/2 plus 15. Okay, and that would be our derivative. Okay, so you have 2 methods to try. I would try each of them and see which one you do better at. So it's going to be a trial and error sort of thing. So try the original strategy, and then try the one here where we make the ribbon. I don't know what else to call it, but that's how a student introduced me to it. She called it the ribbon method, so I've just called it the ribbon method, because it looks like all of those ribbons that we wear and put on our cars and things like that, like autism awareness and AIDS awareness and breast cancer awareness, that sort of thing. So that's what that shape looks like. So it's up to you which one you want to use, just as long as whichever one you pick is the one you are most efficient at and most accurate at.